inside uniform density planet. So just like we did for charges. So if you're at a certain point, how much mass is enclosed in there? So G is going to equal Gm enclosed over R squared, where R is your R, whatever your distance is from the center. The mass enclosed is going to equal the integral of the density times dV over R squared. So we need to find out how much mass is enclosed inside of little r as compared to the total mass of the planet. Okay? So if the density is constant, then it comes out of the integral. So let me just write G without the vector sign all the time. So we just want to know its magnitude now. So G times rho, the integral of dV just becomes V enclosed. And then the density is the total mass of the planet divided by the total volume of the planet. So mass of the planet divided by total, let me write it this way. The density rho is going to equal the mass of the planet divided by the volume of the planet, 4/3 pi r cubed. Big R is the radius of the planet, and then little r squared is the r that you are at, and then volume enclosed is the 4/3 pi little r cubed. And the 4/3, all that cancels, and what happens? R squared cancels one of the r's, and you're left with G is equal to Gm over R cubed times R. Okay, and just like I said for electric field, you should make sure that the equation you get is continuous at the surface of the planet. So if I put here little r is equal to big R, I should get Gm big R over R cubed, I should get Gm over R squared. Okay, so it should be continuous. So this shows that the gravity goes linearly, increases linearly as you get to the center of the planet, as you get to the surface of the planet, then decreases there as 1 over r squared, proportional to 1 over r squared. So what would be halfway, if you go halfway to the center of the Earth, what would be little g? What would be the value of little g? Well, if the Earth was uniform density, then since it's linear, right, if this value is 9.8, halfway will be 4.9. So that's a good way of losing weight, you know. If you're a 200-pound person and you go halfway to the center of the Earth, if it's uniform density, you would weigh 100 pounds. Okay, quarter of the way to the center, you would weigh quarter of 200 would be 50 pounds, right? So you just keep going. So G goes down linearly to 4.9, and then your weight also goes down, okay? How about non-uniform?